At last count, there are 118 confirmed elements in the periodic table. Yet, out of that huge number, you're more than 9 times more likely to come into contact with just 5 than the other 113. That's because out of all of the dozens of elements found in the Earth's crust, it's those 5: oxygen, silicon, aluminum, iron, and calcium, which make up a total of more than 92%. In fact, almost half of the atoms we encounter every day are oxygen, making it by far the most abundant element on the planet. At the other end of the scale, though, we have astatine, the rarest naturally occurring element on Earth. It's thought that less than 25 grams. That's less than a single ounce of the stuff exists planet-wide at any one time. In fact, it's so rare that scientists still don't know basic information about the element, like what it looks like. In this video, we are going to know about the rarest natural element on Earth, astatine. Astatine is named after the Greek word for unstable, and it's a fitting moniker. It's incredibly radioactive. With a half-life of just over 8 hours even in its most stable form, astatine 210. That means that even if you manage to get your hands on some, after 24 hours just 1/8 of it would be left. The rest having decayed into either bismuth 206 or polonium 210. And that's the most stable isotope. Most forms of astatine have had lives of a single second or less. In its elemental form, things get even more volatile. It's so radioactive that if you had enough to see with the naked eye, it would literally vaporize itself under its own heat. While scientists are sort of able to deal with astatine directly, they can only do so by artificially creating it through nuclear reactions, usually by bombarding bismuth 209 with the alpha particles. Most of what we know about the element therefore comes from theoretical work rather than practical experimentation. For example, we think astatine probably looks like a black solid because it lies in the halogen column of the periodic table. Halogens get darker as they get heavier. Fluorine is essentially colorless, chlorine is yellow-green, bromine is red-brown, and iodine is dark gray-violet. In so, the logic goes, astatine, as the next halogen in the list, should be darker still. Of course, that's assuming the element isn't in fact more like a metal than a halogen, a question that divides chemists. Since astatine also lies along a diagonal line in the periodic table which contains metalloids like boron and silicon. In chemical reactions, it sometimes acts like a halogen and other times like a metal, resisting easy classification even by experts. Despite being so rare as to be practically non-existent, and so confounding that we know basically nothing about it for sure, astatine may turn out to have some pretty important practical applications. As the element decays, it emits alpha particles, radioactive particles formed from a combination of 2 protons and 2 neutrons, which are, for various reasons, really good at targeting cancer cells. Astatine is the Goldilocks of alpha emitters. It emits fewer alpha particles than other isotopes like actinium-225. That makes it less potent, but more focused in its emissions. It has an extremely short half-life, meaning it won't hang around for a long time. Importantly, it only emits alpha particles, the least harmful of the various types of radiation. If scientists could attach astatine isotopes to cancer-targeting molecules, then they might be able to create an anti-cancer treatment that could slice through the DNA of a cancerous cell and leave the surrounding tissue relatively unharmed. When it comes to potential cancer treatments, nothing can even come close to having that same targeted potency. Of course, there's a pretty big caveat to all that. Researchers need to get their hands on the stuff first. Since it's so rare and unstable, that's no easy task, which may be why the element is still officially listed as having no known biological role or uses outside of research. But maybe that's for the best. After all, if we knew it was really important, we'd probably need a lot more than 25 grams of the stuff, wouldn't we? If you like this informative video, please share with others, and please subscribe to my channel for more such content. Thank you for watching.